Oops, yeah. Okay, thank you very much for coming. So today we'll be talking about the ZFS. American says ZFS because they pronounce Z in different way compared to other people. So I would say ZFS. Uh, Others say ZFS, but we're talking in the same. We're talking about the same things, okay, with different pronunciation. That's fine. So that's our topic today. My name is Achmad Mardiansyah, and then I'm from GLC Networks. So this is our agenda. Okay, intro, review, file system, traditional file system, volume manager, and then of course the last one is the ZFS. So for your information, um, actually, this webinar is kind of repetition. Okay, so because previous webinar we had a problem with the demo. Okay, in the previous demo, there were, you know, issue in the disk management, so that's why it was very slow to do the demo. Okay, so hopefully today it's gonna be fast, so that we can practice the ZFS right away. Okay, any questions so far? No? You sure? Okay then. Uh, okay, let's move on. So introduction for those who are new. So we are GLC Networks. We are based in Bandung. We do training and IT consultation. So we are doing MikroTik and other stuff. Oops, sorry. Looks like I have an error here. Oops. Okay, please. Doing troubleshooting a little bit over here. So, okay, what was the problem? Oh, okay. Looks like this one is not correct. Debian security. Okay. Hopefully it's fine now. Yeah, so let's continue. So we are doing regular event, and then my name is Ahmad Mardiansyah. You can just call me Ahmad. I'm user of technology, Linux, MikroTik, Ubiquiti, programming, Python, and other stuff. Okay. So past experience, we are doing several projects in different countries. Okay. Most related to networking. About the webinar itself, we did it since 2000 in 2010, and yeah, you are really welcome if you want to be a presenter sharing your knowledge here. You don't have to be an expert, okay? It's just a forum for sharing your knowledge, experience, information, okay? Uh, right. So, okay. Okay. So again, yeah, questions that is I always ask for everyone. So, is there anyone not from Indonesia? Okay. Is there anyone here not from Indonesia or from other countries? Okay, but usually the default for Thursday is the webinar is in English. So yeah, okay, just continue with English then. Okay, Okay, so just let me know where you're from, okay, so that we know, yeah, at least we know, yeah, we know where you're from, okay, we know, we know better from you. If you don't understand, and then you can write the question here directly to me about the things that you don't understand about these related to this presentation. Okay, so prerequisites. So um, about the ZFS. Before talking about discussing about ZFS, so we assume you already know the concept about partition, file system, okay, volume manager, okay, and then some Linux administration. So we assume you already know that. Anyone from Indonesia? Yeah. Usually people are shy, okay, like what we had in Tuesday. Yeah, when Tuesday usually the webinar is in Indonesian language. Thursday is in English. Okay, let's move on. Okay, so let's start with the storage. Okay, um, because yeah, because ZFS is a file system related to storage. So you like it or not, we will discuss about storage. So storage, a common storage that we are using is hard disk. Yes, correct. Wait a minute. Okay, let's move on over here. Yeah. Okay, hard disk. So this is hard disk. Okay, so this is how hard disk looks like. So we have, yeah, we have a platter here. Okay, so this is the platter. Okay, so the disk. Okay, and then we have a actuator arm. Okay, and then we have a head over here. So that is reading the the platter. Okay, so over here is similar to this one. Okay, and then if you see from the side, if you have a section, okay, a view, we usually call it view, and in technical drawing we call it view. um, yeah, so the hard disk will be like this. Okay, so we have a platter, and then we have heads. And what about the 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 things or areas inside the platter itself? So what we have is here, we have a track. So one track is this one. Okay, so one track, so it's a one circle. Okay, one track is like a running track. Okay, and then track is divided into sectors. Okay, sectors, and then several tracks. Okay, so for example, you have more than one platter. Okay, so platter number 1, 2, and 3. So if you combine them, it will become a cylinder. Okay, as simple as that. So with hard disk, you start the data from the outer track. So this is your sector 0 over here, for example. Yeah, so it's not similar with the CD-ROM. Okay, with CD-ROM you start from the inner track. So this is if this is CD-ROM. Okay, CD-ROM. Okay, if it is CD-ROM, you start from here and here and here and here. Okay, but for hard disk, you start from the outer track, from here, and then this one, and this one, this one, and this one, from the outer track to the inner track. Okay, so yeah, that's how you see the hard disk. Okay, so if you know, oh, our track sector 0 is broken, so you know the physical area where that is. Next, after we do understanding our hard disk, and then the next step what we will do in our storage is partition. Okay, because we want to do partition, right? We don't want to put all of our data into one single partition. Okay, so usually what we have with the way we do partition is depends on the structure that we are using. Okay, so if you use file allocation tables or DOS over here. Okay, so maximum partition, physical partition we have is 4, partition 1, 2, 3, and 4. Okay, but maximum for the DOS partition is maximum partition size that you can have is maximum 2 terabyte. Okay, so which is very big, yes, for normal usage, yes, but but sometimes it's not enough. Okay, I have created a volume that consists of 10 hard disks. Okay, so 10 disks, and each disk has how much was it? 10 or 11 or maybe 12 terabyte. Okay, so 10 multiplied by 12, yeah. So as you can see, 120 terabyte. Okay, 120 terabytes. If you use DOS partitioning system, and then you cannot achieve that one. So DOS system was created long time ago, maybe in 90s, 80s. Okay, and then at the time, seeing partition 2 terabyte is wow, it's very big at the time. But today it's very common to see hard disk with terabytes capacity. Okay, so again, hard disk start from the outer cylinder, DVD-ROM start from inner cylinder. Okay, this is how you do partition. Okay, so you have track, and then you have a cylinder, and then we have a sector. Okay, yeah, so this is how you partition. Okay, so over here, okay, that is C drive. Okay, so let's say we talk about Windows. Yeah, so it's a cylinder 0, head 0, sector 1. And then you have two partitions, C and D, and then this is what happens when you format your drive. Okay, and then this is one tool of partitioning system. Okay, it's very common in Windows. Yeah, right. Oops. Any questions so far? Okay, no. Is it similar with Linux? Yeah, yeah. So partitioning system actually is a wide concept. GPT also, right? It's nothing to do with the file system, with the operating system. No. GPT is common. It's a general scheme. Windows supports GPT as well. Linux support GPT, Mac support GPT. Yeah, so GPT is the system for partitioning your hard disk. Okay. For OPT, dev is just an address on Linux or Unix system. Okay. Because in Linux or Unix, everything is a file. So let's talk about a file system then. Okay, so after we have a partition, and then on top of that, we set up a file system. Why? Because, you know, when we talk about a computer system, what we have? We have hardware. Also, we have software, right? And then we have brainware. Okay, it's the human that is using the computer. Okay, hardware we can see it. Okay, uh, after the hardware we have to install the software, and then for the software itself we divide it into two main categories. First is the operating system, is the software that needs to be installed first before you install anything else. Yeah, that's the operating system. And then when we talk about software, how how can we how to represent the operating systems uh, with files? Yes. So everything in operating system is in the form of files. But um, yeah, But we have folder. Yeah, actually folder is it's a grouping of files. That's the concept. Okay, so because we don't want to put all files in one directory, right? We need to have a way to grouping our files. So that's why we invented a concept called folder or directory. Okay, yeah. So because everything is file, your MP3 is file, your movie is file. Um, in Unix, everything is file, including your monitor, your printer, your mouse, your keyboard. Everything is file. Yeah, because everything is files, we need to have a system to manage those files. So that system is called file system, right? So the file system is a system that control how data is stored and retrieved. Okay, in Windows, for devices, they have their own mechanism to access. But in Unix base, like FreeBSD, Linux, Mac OS, um, uh, Mac OS, what else? Uh, Linux, Mac OS, and other Unix stuff. All devices is represented as a file as well. Okay, so everything is a file. Okay, so it's a part operating system again. Yeah, so it's designed based uh, storage. Yeah, based on storage. It's designed based on storage. So I forgot to put on here. So we have a file system for disk, file system for tape, file system for CD-ROM, file system for network. Yeah. For example, in Windows we have a DOS. Yeah, and TFS. In Linux we have extended 234 XFS. Okay. And then many years ago we have Razer FS. Yeah, that one is quite fast, but not using anymore. Others is like a cluster file system. In BSD, we have UFS, Unix file system, or ZFS. Okay, any questions so far? Okay, no. Oh, I have a question. What's the difference between Mbr and GPT? Well, Mbr is master boot record. Okay, is the first sector in your hard disk. So yeah, so this is your Mbr over here. So that's where we put our software here, software to load. Okay, okay, usually we put a small software in that sector. Okay, the first sector, and then when you boot up, yeah, you go to BIOS, and then from that BIOS you can select from which hard disk you want to boot, right? And then when it boots, it reads the MBR, the master boot record. Okay, so master boot record is just a first sector. Okay, GPT is a scheme for partitioning. It's two different things. Okay, so hopefully you can understand that. That's the difference between MBR and um, MBR and the partitioning scheme. Okay. Okay, so after we set up a file system, so partitioning is done, file system is done. So we create, in other words, we do formatting usually here, formatting the partition, okay, and then we get the files. And when during the formatting, we define the file system that we are using on that partition. Okay, and then we have in Linux, we have a FHS, file hierarchy standards. Okay, so define the directory structure for the whole Linux system. Okay, so start from slash here, which is the root directory, and then we have a slash, what is it, slash bin. This is essential programs. Usually we call it busybox. Okay, slash bin, slash sbin, slash boot. Okay, so we put here in the kernel. So kernel also in the form of files. Okay, what else, etc, etc. We have a user directory, non-essential. Okay, we have a kernel file system here, mounting point, usually in MNT or media. Okay, yeah, yeah. Here's the details. Okay, sorry. Oops, I made a mistake. Yeah, so this is non-essential program. User directories. Oh yeah, so this is mount point over here. User directories over here. Kernel file system, and then other directories. Okay, so that's the explanation. Why do we have lots of files in I mean lots of folders in Linux? What are those means? You know, so that's the meaning. Okay, I have okay. There's a question here. Would you like to send slide to us? Yeah, slide will be available on Slideshare. Okay, so this is traditional partitioning. Okay. Uh, okay, so when we do partitioning, actually we set up base it on sectors. Okay. So as you can see, when we see hard disk, what we see is a sector. Okay, from sector 0 until sector whatever. Yeah, maybe 1 million, sector 1 million, sector 2 million. Okay, 2 million sectors. Yeah, it's possible. Yeah. Okay. So what we do is we set up a sectors. Okay, we do partitioning. Okay, so this is SDA1, SDA2 over here. Usually this is SDA3. Okay, and so on and so forth. Okay, so SDA1, 2, 3, and then we have SDA4. Okay, and so on and so forth. Can we have more than one partition? Yes, this is an example. A very good example of that. Okay, so this is the partition. Okay, and then here's the label for that partition. And then here's the file system for that partition. Okay, as you can see. So we have btrfs and tfs, extended to swap, and so on and so forth. And then here's the mount point. So this is important. Okay. Okay. So this for example, this partition is mounted into which folder. Okay. And then here's the label. Okay. Yeah, name, labels. Okay. And then here's the size. So what you see here is the size only. Okay. But actually the size, they usually don't display the start and stop sector. Okay, so every partition must have a start sector and then end sector. Okay, so for example, you have a sector 0 until sector 999, for example. Yes, sector and sector. So sector 0 to sector 100, this is SDA1, and sector 101 until 250, this is SDA2, for example. Okay, so again sector and then sector. This is start and this is stop. Okay, yeah. And then we have 251 until, for example, 403, for example. This is SDA3. So this is how you partition your hard disk. Okay, the things that we usually do not know when we do partitioning. What we know is, okay, this one is 1 giga, this is 2 giga, 4 giga, whatever. Okay, but actually the system does it for you. Okay, so that's the traditional partition. So after we do partition, and then we do the file system. Okay, so as I said, after we do the partitioning, and then we just format the partition with the file system that we like. So in Linux we use extended 2, 3, or 4. Yeah, the latest one is extended 4. Okay, and then now many distro now is using XFS as their default file system. Okay, file system XFS. With XFS, it is possible to grow, but cannot be shrink. Yeah, so that's a drawback of using XFS. Okay, so after that is done. Yeah, and then you can just mount the partition and then you put the data on that. As simple as that. Okay, next is about the volume manager. So as I said, why do we need a volume manager? Because it gives us flexible way for managing file system. In the beginning, when we do partitioning like this is very rigid, okay? So from this sector to that sector, what happens when the partition gets full? We cannot do it because, well, because other sectors are occupied for other partition, right? We cannot easily grow our partition. Yeah, so that's why we developed the volume manager. It's an abstraction layer so that we can manage our partition better. Okay, so the concept here is, okay, there is a special there is a special what is it, special webinar for dedicated for volume manager. Okay, because uh, because to understand ZFS, because ZFS is an advanced feature. Okay, and then that ZFS combines the file system and then the volume manager. So before you go to ZFS, you need to understand how file system works, and then the volume manager works. Okay, so this is, I just give you a brief introduction about how volume manager looks like. Okay, so you have a physical volume, aka the physical hard disk. So you combine those hard disks into volume group or VG. Okay, and then from this VG you split into the logical volume. So this is the things that you consume. Okay, so this is the partition. Okay, okay. So for example, I have 10 hard drive. Okay, and then each has 12 terabyte. Okay, so I want to create a partition that has a size of, so I need I need a folder. Okay, one folder. Yeah, so this is the case. Okay, in this is a case in a real situation. For example, you need a drive. Okay, that has a size of, for example, 30 terabyte. Okay, so the question is there any hard disk in the market that has 30 terabyte of size? Can you let me know? Nobody? Yeah. Can you give me a hard disk, one hard disk that has 30 terabyte size? Only one hard disk. I've searched in Tokopedia, in Amazon, eBay. I don't see this kind of hard disk. Okay, so how can we do that? So by using volume manager. So we have 12 hard disks, 12 terabyte hard disks. We can combine them. So with this one, we can combine with this strategy. So 12 terabyte. This is 12 terabyte. This is 12 terabyte. Okay, so three of them. Okay, and then we group them. So 12 terabyte times 3, we have 36. So 36 terabyte over here, aggregate. Okay, and then so we split, so 30 terabyte here and then 6 terabyte over here. Okay, and then we use this as file system. Okay, so that's the idea of using volume manager. So this volume manager um, is used in enterprise environment. If you have for small enterprise, small business, well, the data is not exceed maybe 1 or 2 terabytes unless you put off your movie over there. Yeah, it's very hard to find this kind of case because buying storage that has that big amount of a huge size of storage, it can cost money, yeah, and then not all companies needs that. Okay, so yeah, the thing that I want to tell you is the logical volume manager like this. Okay, so yeah, for example, yeah, as this is another case, yeah, let's say so this is we have a 36 terabyte. So let's say we just only allocate 1 terabyte over here. Okay, so we still have a 5 terabyte left as a reserve, right? So if this one is full, we can increase into 2 terabytes. Yeah, so the remaining will be 4, yeah, 4 terabytes. So it's the volume manager makes us easier to manage our storage. Okay, so hopefully you can understand that one. So again, we start from PV and then VG and then LV. Okay, and then after that we set up a file system on LV. Okay. Any questions so far? No? Okay. Now let's talk about Zettabyte file system. So this is a Zettabyte file system. So let's talk about the features. Okay. Features is end-to-end data integrity. So this is very cool features. Okay. Yeah, checksum and then copy on write. Okay, the scrubbing and then red Z protection. So ZFS combines the partitioning and then volume manager and then file system in one pack ZFS. Yeah, it has easy administration, only 2 commands, either zpool or ZFS. Yeah, there is the ZFS interface, of course, but uh, ZFS was originally sorry, was originate from Sun Microsystem now, and after that Sun was acquired by Oracle, so now it's Oracle ZFS. Previously it's Sun ZFS. It was released in 2006, and then at that time it was very cool file system available only on Solaris operating system. Yeah, I wrote some articles about that, and then it was very cool. Okay, because it combines many things: the file system, the partitioning, and then the volume manager. It's very good. Immense capacity. Okay, so as I said, zettabyte file system. So we have a megabyte. After megabyte, we have a terabyte. After terabyte, we have petabyte, and then after petabytes, I don't know. And then whatever, blah, 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 and then we have a zettabyte. Okay, so this file system is already designed to handle a zettabyte size. Okay, it was very huge size of storage. Okay, uh, uh, okay. How can we achieve that kind of features? First is 128-bit metadata. So as you can see, with 128 bits, it means that 2 to the power 2 to the power of 128, okay, a file system or information that can be handled by this file system, which is very huge. Okay. Zettabyte file system, it means that you have lots of file. Okay? Remember, software, when we talk about software, is the representative of the software is just a files, right? So you click the files and then the software is open. Okay, so it means that if you have lots of files, if you have a big capacity and then that capacity is big, most likely you have lots of files inside, right? Yeah, we have a compression, we have deduplications, high performance, and so on and so forth. Okay, so this is ZFS features. Next, this is a copy on write. With these features, we don't have a journaling system. Okay, so journaling system means in other traditional file system, it means that when you write something, you write a journal. So if you update a sector, remember sector, right? So you update this sector, you write a journal. You update that sector, you write a journal. So it means that the operating system knows where you are. What is the useful things about that? Especially, it is very good when you have a problem with a file system. For example, if there is a blackout suddenly on your file system, so you need to do recovery, right? In order to do recovery, and then you need to know which last files that you edited. Yeah, the way you do that is by checking your transaction journal. Okay, so that's why we have a journaling file system. Okay, it is very good for journaling file system is very good if you have a problem with the file system, especially if you have a corrupted file system due to blackout or other reasons. Okay, so they invent, okay, why don't we skip the journal? Okay, because the journal sometimes and often makes our system slow. Yes. Okay, so what's the idea? Okay, so we skip the journaling file system. Okay, so we skip it. Okay, what will be the replacement? Yeah, so this is how you update. Okay, so when you update the files in traditional file system, you just replace the sector. Okay, you replace the block. Sometimes we call sector, sometimes we call it block. Usually we call it block. Okay, so there's a block of file system. Yeah, in file system, the data is stored in blocks. Okay, so we update the blocks. Okay, just replace the block. So every time you save your Microsoft Word files, whatever files, Excel, yeah, whatever. Okay, you have software, right? So you just replace the blocks. Okay, but in ZFS, you're not replacing. You are putting other new blocks for that replacement. Okay, so this is old. So over here, okay, this is old blocks. The orange one here, this is new block. Okay, so this is original data, this is new data. Okay, understand? Yeah. So after we update, after we successfully write down the new data, and then we update the pointer over here. Okay, and then the files will do the pointer to the new block. Okay, yeah, this is very good solution. So what happens if there is a blackout here, and then the pointer is not updated. So the files is still pointing to the old block. So it's no problem with that. Okay. Yeah. So yeah, that's how the ZFS works with cow. In database, we have a similar concept called transaction. Okay, it's basically it's all or nothing. So you have if you're using MySQL, Oracle, or PostgreSQL, there is a how can I say? In one single execution, you do several SQL commands, and then you have to make sure that all SQL command executed successfully. Yeah. If one failed, and then you just roll back everything. So same concept applied on the file system, which is I think very brilliant at the time. 2006, man. At the time it was Solaris 10 update 3 or update 4. Yeah, on x86. Okay, so any questions so far? No? But hopefully you can understand the how the ZFS works. Okay, so next thing is about end-to-end checksum. Okay, so this is also cool. So checksum are separated from the data. Okay, so how can you make sure that your data is always consistent? Nothing, right? So you just realize, oh, okay, my file is corrupt. Is there any way to make sure that your data is always in the good shape? You don't have that, but with the ZFS you can. So for example, with self-healing data, for example, with ZFS mirror. So yeah, with the file manager, you can set up a mirror here. Oh yeah, perhaps we can set up another webinar for RAID. Yeah. Okay, next topic. It's a good one. Okay, let me write them down first. Ah, okay. RAID, yeah, RAID. RAID software. Okay, wait. Yeah, I think RAID is a good topic. Yeah, RAID on software RAID. Yeah. So basically, if you do RAID, there are several types of RAID. Okay, it can be done by hardware or by software. Okay, with ZFS, we can do RAID by software. Well, in Linux as well, you can do the same. So with, for example, we have a RAID 1. RAID 1 means mirror. So you have two hard disks, okay, 1 and 2, and then you are mirroring to each other, okay. So if one block here will be similar to the block over here, but sometimes the block over here is broken. So this one is good, and then ZFS will detect that, and then ZFS will recover the bad copy, which is very good, right? Okay, so okay, let's do the practice now. Okay, I will share my command line here. So this is my Debian system. Okay. Okay, so let's see how many disks we have. F disk minus L. Oh, okay, so we have a lot. Oh, as you can see, I am using LFS now. So yeah, as you can see, I have Wow, I have a lot. I have lots of disk here. I have SDE. Okay, I have SDD, SDF. I have sorry. Maybe we can start here. SDL over here, and then this is a 200 megabyte. Okay, or perhaps we can use CFDIS. Oh yeah, this is SDA. Okay. CFDIS/dev SD. Oh, okay. So we have a lot here. SD. What is it? F or H? Maybe H. Okay. So as you can see, I can select the skimming partition. So I'm using GPT over here. Okay, and then I create a new a partition, so it became SDH1, and then I write them down. Okay, type yes, and then done. Is very simple. And then you can do formatting mkfs dot extended 4, and then on to SDH1. So this is one example of how you format the partition. So this one over here, this is partitioning, okay, and this one over here is formatting, okay, and then formatting with the file system, and then the file system we are using is extended 4. Okay, so if you want to use, and then you can create the directory mnt sdh1. Okay, so and then you can do mount /dev sdh1 into mnt sdh1. Done. And then you check, and then you are here. Okay, as simple as that. So with ZFS, it's a little bit different. So you can unmount over here. Okay. So with ZFS, you can only have two commands, either zpull or ZFS module is not loaded. Okay, so let's load them. Oh, what's happening? Okay, let's check the modules. Oh, okay, so let's install that. Okay. So it should be okay then. Yeah, so we installed the module here is done. So let me reboot the server. Shutdown -r now. Okay, so let's wait. Hopefully we can use ZFS after that. Is it back? Okay, let's check. Oh. Yeah, well, yeah, actually this one is done previously. Okay, let me check it down. Search ZFS. This one is not working. Okay, let me check etc apt check the source list. We have contrib non-free. Yeah, looks like this one is okay. um okay, let me install one software over here. ZFS modules, ZFS intramfs, or otherwise we can use this one, ZFS on Fuse. No. Okay, no. I think we need to remove aptitude purge the ZFSZ. Okay, and then DKMS. Okay, so we try to use ZFS on Fuse. Okay, blah 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 blah. Update RAMFS. Or if you want, for easier, so I'm using Linux because many people are using Linux. Okay, but yeah, but if you want, you can use FreeBSD. FreeBSD has a ZFS support built in because ZFS is a feature, it's a code, it's an algorithm, and it's not compatible. And then every algorithm has license, and then the license of ZFS is not compatible with Linux. Okay, yeah. So yeah, that's what happened. Okay, so let's install ZFS on Fuse. On ZFS Fuse. Okay, see, license OpenZFS and Linux are not compatible. Okay, understand. So they will do compile. So hopefully everything is okay. They will rebuild the kernel, and then hopefully after reboot everything is okay. Okay, I have a question here. Can we configure ZFS first before installing Debian or Proxmox? There is if you install Proxmox, there is an option for using ZFS, but based on my experience, ZFS on Linux, the performance ZFS on Linux is not as good as if you are using BSD. Yeah, uh, yeah. For Debian, I don't think Debian has an option for ZFS. No, they don't have it. Okay, so we are still waiting for a process here. We installed the ZFS module for our Debian system. With we have options for Fuse. Yeah, so previously it was DKMS. Okay, and then here we have Fuse. Okay, hopefully it's okay. Wow, it's compiling. Wow, it takes time, man. How can we do that? Perhaps I can use the system which already has ZFS on that. So I will log into a ZFS. Yeah. I think I have one. SSH. This is on my lab. 7.252. Is it working? Oh yeah. Okay, so we have, for example, Zpool. This one already has ZFS on that. Zpool list. Come on. Oh, what's happening? Yeah, so as you can see, we have our pool here. Okay, it says free, checkpoint, blah, blah, blah. Other is ZFS list. Okay, so only two commands. Okay, so yeah, Zpool and ZFS. Okay, so Zpool is sorry, is oh, still compiling. Okay, never mind. So Zpool is to create a pool. So it's similar to when you create in LFM, LVM, sorry, LVM. It's similar to when you create a, oh, screen is paused. Oh, sorry. Can you see my screen? Okay, wait. Sharing screen. My terminal. Hopefully you can see it. Yeah. Oh, okay. This is our system, Zpool list. Okay, mode probe. Oh, screen sharing is paused. Really? Can you see my screen, guys? Because I see here, I see my it says that the screen share is paused. Okay, let me reshare. we share again the terminal. Okay. Oh, yeah. I understand now. Yeah, when I change that, it says this screen share is paused. Okay, so meaning perhaps I can use other software for that. Sorry guys. So perhaps I can use Termius for that. Okay, let me open the Termius. So Termius actually is it's a alternative for accessing a command line. Okay, it's over here. Hopefully you can access them. Oops, sorry. Yeah. Okay. Okay, it's good. So let's duplicate. Yeah. So this one I think is much better than the previous one. So if I change the shell, then we are still able to access in 131, right? Oh, a different port. Okay, so we only have two commands, as I said. So this is the pool um, or you can write here minus help. Okay, so that you can see the other options for zpool. Okay, and then yeah, we can check a list. We can check IO start. We can yeah, we can let's say status zpool status. Oh, maybe the file is bigger. Okay, so as you can see, yeah, here's the status, and then so this pool is consists of one hard disk. Okay, so this pool consists of one hard disk over here. Okay, right? Yeah, never mind. So again, the Z pool is a command to create a volume. Okay, and then on top of that, the way you manage is ZFS. So ZFS list. Oops, sorry, ZFS list. Yeah, so here it is. So as you can see, in our pool we have free, yeah, so 45 gigabit free in our pool. So it means that yeah, we can create a partition for that. Okay, so how do we do that? So ZFS, yeah, create, right? Create, for example, what do you want to create? Let's say create a partition with what is it? Yeah. Oh, okay, just create a partition. Okay, create. Yeah, create a partition. So under the R pool. Okay. So we define R pool, and then partition is, let's say, partition 1. Okay, let's say finish. As simple as that. Okay, and then when we do list, and then it will create one partition. So we have pool, and then in that pool we create a partition, and then we can see the partition here is available is 42 gigabyte. Okay, and then automatically it's already mounted. Yeah, that's a cool thing. ls minus l slash r pool partition 1. Yeah, see. So as you can see, ZFS combines the partition, the file system. We don't have to do mkfs, right? Mkfs dot, for example, extended 4, right? Like r pool partition 1. So usually we have to do things like this, right? With ZFS we don't need to, yeah, because everything is already there. It's packed into zpool and then ZFS. Okay, so can we change the mount point over here? Yes, it's possible, yeah. So how can we do that? So ZFS minus help. Yeah, so we can say, so there is an option here for mount points. Where is it? Oh, set, ZFS set. Yeah, okay, so ZFS list. Okay, so this is our device, and this is the mount point. Okay, so we can set up ZFS set, right, minus I forgot the mount point. I forgot the command. Okay, wait a moment. Let me check. Oh yeah, set minus O. O means options, mount point. So I will say I want to mount it on mnt slash partition 1. Okay, mount point equals to, okay, so this is the new mount point, okay, for this R pool. Oh, oh, okay, that's a data set not exist. R pool slash partition 1. Nah, okay, so it works. Yeah, without minus O. Minus O is for, yeah, minus for creation. Okay, so as you can see, this is the data. This is the data set. So this is the original address. And then we change the mount point dynamically. Okay, touch slash mnt partition 1 file 1 dot txt. Oh, sorry, txt. Okay, ls minus l mnt partition 1. Okay, and then we have two files over there, and then we change the mount point again. Yeah, change to blah. Okay, and then check ZFS list. Okay, so mnt blah ls minus l mnt blah. There you go. Yeah, so it's very easy to maintain a file system. Do we need to edit the fs tab? No, nothing. So ZFS already built in. That's why I like ZFS. Okay, let's say zpool list. Is it working? Module is not loaded. Why is that? Hmm. Okay, so it seems like the ZFS installation is not successfully installed here. Oh, sorry. Okay, it's done. Yeah, DKMS is already there. In a TramFS, ZFS modules. Yeah, this one should be okay. I don't know why. Okay, guys, so perhaps we will schedule another session for ZFS. Yeah, so as you can see, yeah, using ZFS is very, very easy. Okay, so, oh yeah, for example, this one, as you can see, the maximum size for that partition is 42 gigabyte over here, right? So we can set up size for that, so that this is very good for hosting system, right? Where if you go for hosting system, usually they have limitation, right? So for that one, we can say, okay, let's check ZFS must help. So we have size, maximum size. Okay, so we can say there is an option here for, is there any quota? Oh, there are lots of them. Okay, let me check with the keyword quota. Do we have that? No? Oh, okay. But perhaps we can try. So yeah, same thing. With blah, we can say quota. Usually it works. So quota equals to 2 giga. Oh yeah, it works. Okay, so let's check. See? So this partition, you cannot exceed. So if you put the files here, it cannot exceed more than 2 gigabytes. Yeah, it's very, very easy. Just set the quota. Done. See? Only this. If you want to change, oh, I don't like this guy. Let's make the quota down to 1 giga. Okay, done. And then let's check. Let's, yeah, so 1 gig. See, very simple for managing your file system with ZFS. Any questions so far? Any questions so far? Hello? No questions? Aptitude. Aptitude is a command for package management. Yeah, for installing or removing software. So because it's not like Windows operating system where you have to click blah 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 blah. Yeah. Okay, so is Facebook and Google use ZFS? I don't know. I don't know. Usually they create their own file system because they have a good engineer at Facebook, at Google. Usually they create a file system like you know, Cloudera. Yeah, Cloudera is yeah using system that is used for big data. Okay. Google create their own file systems, yeah, with their own engineers since their their existence since 2000 and I mean 1990s. Okay, yeah. Well, ZFS was invented especially in Sun Microsystem. Okay. Yeah, yeah. I think I really believe that with that kind of company like Google, they have lots of engineers, very good engineers. So it's not impossible for them for creating their own file system. Yeah. Okay, I think that's all. Yeah, at least you can see it's very good and it's very convenient to manage a storage with the ZFS. Okay, it's very easy and then very comfortable. And you can only you just only use two command, that is a zpool or a ZFS. Okay, guys, so it's time to uh, to end this discussion. Okay, so I'll post here as usual. Okay, your feedback. Slide will be available on Slideshare. Oh, okay. So this one is old, from the old slide. Okay, but you can just go to Slideshare and then you can see our slide over there. Recording will be available on YouTube. Yeah. Oh, sorry, I forgot. So I should post to everyone in the meeting. Sorry. Sorry. Send me history. Oh, okay. History. Okay. So please wait. This system is not responsive. Okay, let me. I just copy and paste. Yeah, it's easier, I think, and then post it on group chat, right? So that you can copy that. Perhaps. Okay, those are the the command on that I type here on my system. Okay, so perhaps you can take a look some of them. Okay, so it's time for picture. Okay, please share your 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 cameras. Yeah. Okay, let's take a picture. I will count 1, 2, 3. Okay, thumbs up. 1, 2, and 3. Yeah. 1, 2, and 3. Yeah. Okay, guys. Thank you very much. Thank you for coming.